I want to talk to you in this series of our virtual lectures about subnet mask and subnetting of IP addresses. Now you should remember, and if you don't, you need to go back and review previous chapters about the classes of IP addresses. You should remember that there is a subnet mask and what default subnet masks are, because that is what we're going to be working with in an effort to change how many networks there are on an address. Before we do that, however, I want to tell you why you would even want to do this. Remember that in a Class C, and for the intents and purposes of this class, we're not going to deal with A's or B's, only C's. You have 256 addresses, 254 of which are usable. And that's plenty for a small company. But you only have one network, and the same thing applies to the A's and the B's. In the A's, you have 16 million addresses, but you only have one network. And this can pose a problem sometimes. Let me give you an example. If you have an Ethernet switch that is servicing your network, and you put in another Ethernet switch, and you link these two switches together, you still have only one network. But should you decide at any point for security reasons to split this by the insertion of a router, now remember back to previous rules. No two ports on a router can be on the same network. This is a port, this is a port. So what has happened? You have created two networks. Well, supposing that you have a number that looks like this for an IP address. That's your network number. Your default subnet mask is going to be 255, 255, 255.0. That's one network. You have two. Now you have a problem. You're going to have to go out and get another Class C, and you can trust me on this, you're not going to get another one just so that you can hook another switch up on the other side of a router. You're going to have to mathematically change the way you're doing IP addressing in order to service two networks. On the other hand, supposing the scenario actually looks more like this. You've got an Ethernet switch servicing a LAN, and then somewhere in another town you have another Ethernet switch that's servicing a LAN, and you want to connect them by a WAN link, creating your own LAN. This is not going to be done the way I drew it before with a single router. This is going to be done with two routers. And so what you end up with is a router here, this switch hooked up to this router, this switch hooked up to this router, and your WAN link connecting the two routers. Now, how many networks do you have? Believe it or not, you have three. Even though you only have two switches, you have three networks. 1, 2, 3. This link has to be a network all of its own. Why? Because of the rule, no two ports on any router can be on the same network. Port, port, same router, got to be separate networks. Port, port, same router, have to be on separate networks. But this one, however, it's not separate ports on a single router, it's separate ports on two routers, and the opposite is true. They must be on the same network. So by default, you have three networks. So when you're counting a schematic on an exam that I might give you, you're going to need to count how many LANs there are, and you're also going to need to count how many WAN links there are to come up with a total number of networks. Okay, now, there are certain things you can change, certain things you cannot change. For example, with this IP address right here, you have a subnet mask that looks like that. You also know that this part of your IP address your network address, represents the network, and this part represents the node. The exact same principle applies to your subnet mask. This part, which is represented by all binary ones in an 8-bit package, you remember this from previous chapters, in 8 bits, all binary ones is 255. This is the network portion of your subnet mask. This is the node portion. In your IP address, you cannot change the network portion, but you must change the node portion. Same thing applies to your subnet mask. You cannot change the network portion. But if you want to subdivide into more networks, you must change the node portion of your subnet mask. Now, in previous chapters again, we learned that this is a number that can't be changed, and now we're changing the rules and dividing it down just a little more. This is the number that can't be changed. This is the number that has to be changed. The first step in all of this is to determine how many networks you need. That is your first step. Now, you have to trust me on this. When you're taking your Network Plus exam, or when you're taking the exam that I'll give you on this concept, the mathematics of all this is extremely simple. It's the number of steps that if you get them out of order, you leave one out, you don't do them all, you're going to end up with a wrong answer. And so those of you that think, oh gosh, math, I hate it, don't worry about that. This is nothing more than addition and subtraction in a list of steps that long that cannot be done out of order. So let's take a look at this. Step number 1. Determine how many networks you must have. All right, let's come up with an arbitrary number, and then let's go from there. Let's say, for the sake of argument, that I have got to have 5 networks. I must have 5 networks. Remember how the verbiage goes, usable. And remember back when we discussed IP addressing, I said the first address cannot be used because it designates the network. The last address cannot be used because it's the broadcast address. When you're subnetting, the same principle applies to networks. The first network you use, you can't use. The last one, you can't use for the same reason. Now be logical. If I need 5 networks, and I already know that I'm going to lose 2 of them, then I should not mathematically subnet for 5 networks, because when I'm finished, I'm only going to have 3. So step number 2, take step number 1 and add the number 2. I need 5 networks. I must add 2 to it, because in real language, I need 5 usable networks. So if I'm going to lose 2, I am going to have to mathematically subnet for 7 networks. I've just covered the first 2 steps. Determine how many networks you need, add 2 to it. Step 2, add 2. Simple as that. Okay, I'm going to mathematically subnet for 7 networks. That's been determined. Now, how do I do it? I have already done the powers of 2. Keep in mind that when you take your Network Plus exam, you are allowed to create that chart before you take the exam, as long as you create it in the exam room without looking at a book. And this is an easy chart. You don't even have to know the powers of 2 to do this. All you do is write down 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 5, 6, 7. Put in your equal signs. 2 to the 0, memorize it. It's 1. If you want to know why or how, go to the math department. We don't care. 2 to the 0 is 1. The rest of your answers are simply doubles of the previous answer. Double 1. 2, put it there. Double 2, 4, put it there. Double 4, 8, put it there. 16, 32, 64, 128. I told you, this is all going to be simple addition. Add these numbers back to themselves. Now you've got your chart. You're going to need to refer to this chart. There are several key numbers that will be found in this chart. Bingo. Which is the first one? I am going to mathematically subnet for 7 subnets, knowing I'm going to lose 2, and I'll have 5 usable. I go to the answer column over here, and I choose the number 7. It's not there. I go to the next highest number, which is 8. I'm now dealing with that number. This equation is going to give me a key phrase, a key number. That number is the number 3. I want 7. I choose 7. 7's not there. Go to the next highest number, it's 8. Now I have the exponent, and I am going to do something with that exponent. What am I going to do with it? I'm going to take this 0, and I'm going to write that 0 in binary code. Who can't write the number 0 in an 8-bit number? 1, 2, 3, 4, 5, 6, 7. What am I going to do with that 3? Starting from left to right, that number is how many of these zeros I am going to change into ones. Now, the last octet of my subnet mask will be I just changed my subnet mask. Changed it to what? 128. Isn't that what that one's worth? Plus 64, 192, plus 32, 224.
Mr. McKay,
Sir,
isn't there supposed to be 8 zeros?
why no, but thanks for asking. Yes, my mistake, sorry. And then I proceed to put it on the wrong side. Okay. I've come up with 224. What am I going to do with the 224? Folks, that's my new subnet mask.